So welcome everyone to Tuesday training. Today we've got something very exciting to share with you in the form of wearable, mobile and deployable networks from HIFA. To the unfamiliar, HIFA is a suite of solutions that provides intelligent connections using Wi-Fi and mesh technologies to enable users to connect smart devices like radios, sensors and cameras and other devices in environments that defeat radio and cellular communications. So to explain this further, we have Mick Hughes from HIFA. Welcome, Mick. Thanks for joining us.
Thanks, Jason, and thanks everyone for attending today. So what I'm going to do today is just basically introduce you to the HIFA radios or HIFA mesh network system. We are a company owned by Wireless Innovation. You've probably heard of Wireless Innovation out of Brisbane. I'll then go through the product offerings that we have, a little bit of Sales 101, and then some use cases. I've got the actual products here behind me, which I can just do a quick run through of as well. And then take questions at the end for anyone who's got any questions as well. So thanks, Jason, for explaining what HIFA is. HIFA Mesh, which is in an ecosystem of solutions and products that we've got out of Wireless Innovation. So we've always been specialists in satellite communications, but now we've branched into mesh communications with the release of the HIFA Mesh products, which we'll go into shortly. We have expanded our global capabilities to deliver not just the products, but also applications and software that run behind it. And you know, the value proposition there is to allow organisations to operate effectively, efficiently, and above all, safely. The name HIFA, for anyone who's interested, came from basically a natural network that organically joins up many plants in the forest. If you're not familiar with mesh radio networks and systems, the main difference I would say between a standard P25 or LMR, DMR network is that you know, it's point to point pretty much. And if you want to get any further, then you need to put a repeater in between yourself and the high point, which gets back onto the network. Whereas in mesh, every single radio is a repeater. That's the easiest way to explain it. So the mesh joins up many other mesh radios in the area of operation, allowing everyone to communicate and share not just voice, but also any data, anything that's IP compatible, because it's IP transparent. So it doesn't matter whether it's a camera or whether it's metadata, GPS locations, or anything will be able to be transmitted over this network. So the solutions offer a dedicated, secure, IP transparent network. It's based on the COFDM waveform, and we'll go into why that's important shortly. And we can operate independently or integrate back to a central core or wider network via an ISP, leveraging existing internet backhaul where available. So with these particular mesh radios, if one of the radios has a connection via cable, via Ethernet into any ISP, and that might be via satellite or it might be via LTE. So the mesh network is software defined, builds a self-healing, self-forming network, ad hoc network. So you can see two examples, or four examples really, but the main examples there at the top left is a network where all radios are connected into a star network, and that could be in any shape or form, as long as each radio has connectivity via RF, or you can extend out. So for example, you know, we've had well over 5 miles of extending out an IP network just by, I guess, breadcrumbing out into the area of operation. And we'll see an example of that in real time later. And so why that matters is because for each radio or each node that you have that's out in the network, it actually has what we call a Wi-Fi bubble around it, which we've tested out to 90 meters with Motorola down in Tally Ho in Burwood. And so that means any Wi-Fi enabled device can connect to a node anywhere in the network and either participate in just that fixed local network, or if one of the nodes is connected to an internet service provider via LTE or satellite, then you can connect back into your communications government radio network, for example. So there's lots of mesh out there, and there is lots of high-end COFDM type meshes out there from such providers as DTC, Code, which is now owned by Codan. There's Persistent Systems, there's Silvus, which has had a bit of a footprint here in Australia as well. But what we've done is we've actually taken that same technology, which is being used by defence and military, and you know, most of the I guess more financial law enforcement agencies. We've put that into a purpose-built radio for emergency response, and we've priced it accordingly. So rapid deployment, dedicated and secure network, no infrastructure required, simple to operate, one button, we'll see in a second, and a ruggedized portable device, which is at IP67 rated. The people that we're targeting: wildland firefighting, search and rescue, disaster response, technical rescue, so such as caves, and even coverage of special events that might be happening in LTE or other communication or radio denied areas. You should be able to deploy a mesh network and have communications back up and running really quickly. As an example, one agency that we were speaking to had a quote from Motorola to get in-building coverage on a distributed antenna system of $1 million to cover that whole building. And there's 200 buildings in the city, whereas with this particular solution, you should be able to just run in there with a what we call our range extension kit, REX kit, and have or achieve the same result. As long as your portable radios are Wi-Fi enabled, which we'll also go into. The product range is here. So starting from left to right, we've got the HIFA CAP, which is the communications access point. We've got a HIFA PTT, so press to talk, exactly as it says. It provides a voice and PTT interface in one handy package if voice is all you really want to do, although you can actually hook in via an extra cable. You can hook in HDMI video feeds into that as well. All of these devices are GPS enabled, and will show dot on map. Then we go into our fixed or vehicle offerings. The one that looks like it's got an orange stripe on it there, third from the left, is what we call our MAP, our mobile access point. And then we've got high power offering, which is our node. That particular one there is 2 watts. We also do 10 watts. And then our deployable, which I've spoken about in the last slide, which is our range extension kit, which is the REX kit. We've had that all of this was designed and built based on feedback. We've done extensive field trials with earlier versions of this and different configurations, particularly here with Fire and Rescue New South Wales, and also over in the States in California with Western Fire Chiefs Association, and a lot of people from different fire brigades over there. And that's how we've arrived at these particular items and how they physically look, how they physically operate, and how they're packaged. So what we sort of see as our key here, and the one with the biggest unique selling points within the mesh marketplace, is the communications access point, the CAP. It's lightweight, portable. It has a visual indicator to see whether it's in a network, but most importantly, second most importantly, is it's only got one button. If you are a 6-year-old and can connect to your internet at home, or you're an 86-year-old and can connect to your internet at home, and everyone in between, then you can use this device, because that's as simple as it is. Turn the button on, see that it's got a green light, search for the SSID, and log into the network, and you're away. So it's a secure IP network in that it's AES 256. We've got a 12-hour battery life. So this is based on feedback out of the US wildland firefighters with a hot swap battery. No other, at this stage, they'll catch up, but no other mesh radio on the market has a hot swappable battery, which allows you 6 hours without a battery and 6 hours with, resulting in 12 all up. Data rate up to 60 megabits per second through the whole link. A range in excess of 1 kilometre between nodes. We like to downplay that and overachieve when it comes to demonstrations, and then customers coming to us and saying, well, you know, we got further than that. That's great. Well, and we would expect that. The COFDM waveform, as I said, is in use with Defence and the bigger budgeted law enforcement agencies globally. So this is the first time that this COFDM waveform, this technology, has been cheap enough for or to offer into a more mass market, such as first responders, who are, you know, probably 10 or 20 to 1 when it comes to those guys, the bigger players. And as I said, it connects Wi-Fi capable device to any Wi-Fi capable device. So just pop and prop right there. Hopefully you can see here. What I'll do is do a little what's in the box. So this is the HIFA cap as it stands. And I'll try as best I can without everything spilling everywhere to show you. Okay, so in the box, what we've done is, and nobody else in this field does this either, is everything that you need that you could possibly think of to make this device work and connect and to program it is in the box. So there's no, oh, well, I have to buy, do I have to buy a license, or oh, do I need antennas? All that sort of stuff, it's all taken care of. So you've got your device. You've got your quick start guide. And then in the device itself, desktop charger, vehicle charger, which is a clip-on device. You've got another battery, so it comes with 2 batteries. Ethernet cable, carabiner for hooking onto trees and such out in the field, and your power supply, which is used for your desktop charger. So all that comes in the box when you order a cap. Moving on to the MAP, a mobile access point. So that device, if you look at the footprint of these, it's not much different to an iPhone. Even the communications access point, we've tried to make it as small as we possibly can. So obviously it's a bit more beefier when it comes to the side profile, but the front profile is as it is. So we've also tried to make as good as possible our interfaces to be commercial off-the-shelf interfaces. So this is actually just a basic switch as well as a mesh device. It's designed for vehicle mount. It comes with a removable bracket. Okay, here's one I prepared earlier. So that mounts anywhere on the vehicle or anywhere you want to put that. Might be a mobile communications vehicle with a desk, and the map slots into it. The data rate, as I said, is the same as the cap, 60 megabits per second, 2 Ethernet, 2 mesh, 1 Wi-Fi antenna to extend your Wi-Fi into a high gain antenna that you might find on a vehicle. Also GPS, so you can mount this under a seat at the back of a seat, and then extend out to the GPS antenna and still allow your location to be seen. Again, it's got a range in excess of a kilometre. It'll be more, and particularly vehicle mount, where it allows for higher gain antennas. The antenna gain on the cap, for example, is 3.1 dBi, and the MAP antennas at 6 dBi. Next up, the REX kit. So I'll see if I can show that without tipping it. Okay, so that's your REX kit. You'll see that it's got 3 caps in here. It's got a map, desktop charger, vehicle charger, your 6 dBi antennas. It's all neatly packaged. One of the other advantages of the map is we've built it so that its lid can be removable, and a slide for, in this particular case, the Cradlepoint IBR 900 slots straight on. So that can be mounted, for example, here in the lid, if you wanted to sell it as a package that was for people that were responding to search and rescue or unplanned events, or it will slot straight over here into the side of the case. It also comes with options. We've got a configurator tool that you can use to, if you wanted to have sort of power plugged into the side of the box, RJ45 connector into for Ethernet into the side of the box if you wanted that. So everything. Yeah, pretty much everything that we supply so that it will be a standalone working out of the box unit. You don't have to ask for accessories unless there's a use case that your customer has that wants that. So we also have a free of charge monitoring and configuration portal, or what we call an engineering program. And there's 2 ways of programming these devices. If you know the IP address of the device, you can browse to it by any browser and then enter it via password, and you'll be able to do basic configurations such as change frequencies, change bandwidth, and monitor the network. So example here on a phone is monitoring the network, and you'll see that the green lines between the black dots, which represent nodes, are your link status with a figure, which is the SNR figure above the noise floor. Further to that, the program also has the ability to upload maps, be it street maps or in this case, a satellite map, and you can show the dot on map as long as you're in an outside area. It's GPS, so it will not work inside, but once you're outside, if it's wildland fire people that you're talking to, then it'll be just fine. We also enable API integrations. We've got OEM parts for you as well. If you wanted to put it into your own housing, for example, we can facilitate that for you too. So just recapping on the REX kit, it is portable, it's easy to use, everything's in the box that you need straight out of the thing. Simply add power and you're away with a connected network with 4 nodes in it. So some of the testing that we've done, and I'll touch on the Australian ones shortly. We connected up to the FirstNet network in Boise, Idaho. We were connected into satellite with the U8. If anyone knows the Kymeta U8 dish, we've connected in with that. We've also flown it in Florida and Torrance in California with the UAVs as well. In the CRD scenario here, you can see here we had 4.74 miles across water, which is where the nearest LTE coverage was. So we weren't using satellite in this scenario. And we were able to then extend, as you can see, the caps walking around into the valley where they'd never had communications ever before. There's no LMR or anything there. And we were able to go a mile up the river. We could have gone further. We actually got a link across the top of the ridge, which we think was coming from the node over here, but we didn't display it here. So for those that know about ATAC, you'll probably sort of kind of see that that's ATAC. So we can be displayed in ATAC and dot on map and all the rest of that sort of stuff as well. So one of the things that we were doing in, I think it wasn't Missouri, I think it was in Boise. We were down a canyon. One of the guys took out his ATAC tablet, and he was able to update fire fronts and other information, which was then transmitted across the network up to the car park where the commander was in live time. So, and that was without LTE connectivity. So it was completely off grid. So Missouri Task Force 1, we did quite a comprehensive test with those guys at one of the Air Force bases. And there was it consists of rubble pile search, wide area search, and UAS Overwatch streaming. And I've just got to emphasize, everything that we did was utilizing their own devices and applications. So we just come to the party with the mesh, I guess the wireless blue line, and they can connect everything that they've got today into the network, which makes it really appealing for first responders. It's actually an interesting story happened down there. One of the guys wandered off and succumbed to heat exhaustion, and he was able to use his phone and Wi-Fi call back up to the base of operations and ask for assistance, and they were able to find him using the dot on map. So an unintended scenario and demonstration, but a demonstration for us nonetheless that worked. So the rubble pile, typical scenario that we find, it's no communications between the base of operations. A typical example which is coming up now will be the Ukraine, of course, where all of the communications have been blown up and bombed out, or in weather events where none of the, and fire events where none of the LTE towers are up anymore, none of the GRN towers are functioning, and these sorts of things simulate that. So the CAPS provided Wi-Fi access at rubble pile connected to the LTE backhaul, which was located a quarter of a mile away in this scenario. You can see here two examples of the screen. One is at the top is the free GUI that I was talking about earlier, and the one at the bottom I think is ATAC. So people utilising ATAC to do everything that they do today without us having to, do any significant interfaces or code writing or anything like that. It's a further, so that was same area. They just went across the road. There's a big interstate highway. So we staged the Rex kit at the base of operations. The drone truck drove a mile east across the highway. It maintained a strong mesh link back to the base of operations anyway. Another team went north about half a mile, maintained the link to the drone truck. The team used their field data collection app, Esri ArcGIS Quick Capture, which is the operating system that the USARs use there. And they were able to record field observations, send data back to the BOO in real time, and searching and assessing damage. All sorts of things that they need to do in the field, which is hamstrung when there's no communications, especially data communications going back. So we could see there, track them in the field. They were talking over the network, and they were able to exchange data, be it mapping software or, mapping and those sorts of things, so location stuff. We were able to put it up into the air. The example here on the right, you'll see the imagery being transmitted down into the base of operations. That was over the mesh network. All of this stuff is ad hoc. We've rarely gone to a demonstration where it was, I guess, scripted. So we want to do this, we want to see that, we want to do this. It's never really worked out that way for us, unfortunately. But fortunately, because we are a transparent network, and once we've got connectivity, we can pretty much ensure that anything that they want to use data-wise can go through there. A really good example of that, we're in St. James Tunnel underneath Hyde Park in New South Wales. We were there to test communications via the Motorola XBS back into the government radio network there, back to the console, which I think is in Newcastle. So we established that on the ground, so underground. Then they took out Firecam, which was unscripted, and they were streaming Firecam onto the whole of Fire and Rescue New South Wales's network. And then Graham Tate, who was there, pulled out his phone and then logged into the network and was viewing the streamed footage. So it was all over one device, streaming up to out from underground in the tunnel. And then one of the other fellows decided to watch YouTube. So some V8 racing, I think, on YouTube. So all of that sort of thing happens in these demonstrations, and so far we've been able to accommodate that. So additional case studies that we've done: wildland firefighting, search and rescue. So that's probably pointing towards the things that we've done down in the tunnel at New South Wales. We've also done some testing with Motorola in Burwood with their current Smart Connect system and Wave, and we've been able to facilitate voice over IP for those guys into Smart Connect. But more importantly, we've been able to transmit via the use of one of the ports that they've got, that they transfer their metadata, their GRS and their location over. So we're able to also demonstrate that, which is, by all accounts, a bit of a win. So this HyperMesh system will facilitate that. We've also worked with Harris and able to facilitate voice communications from a Wi-Fi enabled portable. I think it's the XL200, I think, might be the XL400. And that was, so Wi-Fi connected to the SSID of the mesh that was near the radio. That then went back through IP through into their server that was based in the US. So that's their training server, and then back to us via another mesh node and into another handheld portable with around about 30 milliseconds delay and excellent audio. It was quite amazing. It was really good to see. So we've been able to do that. We've also been able to do that over satellite as well with the Harris radios. We haven't done that with the Motorola's, but in theory, that shouldn't be a problem. So coming to an end.
So Mick, thank you very much for showing us the HyperMesh solutions.